There are three methods: priority list method, dynamic programming method, and Lagrange's relaxation method. For your syllabus, you have the priority list method and dynamic programming method. So let us see priority list method first, then we will move on to dynamic programming method. So priority list method. So this is the one of the simplest unit commitment solution method, one of the simplest unit commitment solution method, which consists of creating a priority of list of units. So here we will create the priority. We will create the priority of the units, priority list of the units to commit to commit. So this priority list will be based on the full load average production cost of the each unit. The priority list of the unit based on the full load average cost production cost, full load average production cost of the unit. So this full load average production cost can be determined by the net heat rate at full load, net heat rate at full load into fuel cost, net heat rate at full load into fuel cost, where heat rate is nothing but it is the input fuel, input fuel divided by the energy output. Fuel input divided by energy heat rate is the fuel input by energy output into fuel cost will give us the full load average production cost for the any given unit. So based on this full load average production cost, we will prepare the priority lists in ascending order. So here in this method, we will assume some of the assumptions in this method are cost assumptions. First one is the no load cost. If the generator, if the any plant, any unit is not loaded, then no load cost is considered as zero. No load cost is considered as zero, and the unit input and output characteristics are linear between zero output to full load. So if you consider the input and output, the curve between input and output should be linear like this. Input and output should be linear. And the startup costs are a fixed amount. Here the startup costs of the any considered unit should be considered as fixed amount. And here, if you consider the thermal units, we should ignore the minimum uptime and minimum downtime. So this is one of the constraint in the unit commitment problem. So here we will assume this, we will ignore this minimum uptime and minimum downtime. So this priority list method, that steps to be followed to solve this unit commitment problem using priority list method. So first of all, we need to determine the full load average production cost of the for each units, full load average production cost for each units. And next, we need to form the priority order based on the average production cost. We need to form the priority order based on the average production cost in ascending order and commit number of units corresponding to the priority order. So depending on the priority order, we need to commit the number of units. So we need to calculate the power generated by units Pg1, Pg2 up to Pgn from economic dispatch problem for the feasible combinations only. First, we need to determine the economic generation of the all three generators select of the all the priority order generators. We need to calculate the economic generation for the load curve shown. So if the as I shown in the previous class, the load curve which is always not constant, which varies from hour to hour. So with reference to the load curve, assume the load is dropping or decreasing. If the load is dropping or decreasing, then we need to determine whether the the drop in the load will the next unit will supply the generation or and spinning reserve. So when the load is decreasing, if any of the unit is dropped, determine whether dropping the next unit, dropping the next unit will supply the generation plus spinning reserve. So if the load is decreasing for any hour in a given day, then we need to determine whether the dropping the next unit, that is the committed unit. If you drop the committed unit, then the remaining will should supply the generation plus as well as the spinning reserve. If not, then this continue as it is. If yes, go to the next step. Next, we need to determine the number of hours before the unit will be needed again. We need to determine the number of hours before the unit will be needed again, and check number of hours should be less than the minimum shutdown time. Number of hours of the units turned on should be less than the minimum shutdown time. If not, go to the last step, that is again we have to repeat the procedure for in the priority list. If no, then we should go to next step. Calculate the two costs. One is the sum of the hourly production cost for the next H hours. One is the sum of hourly production cost for the next H hours with the unit up, and second one is the recalculate the same for the unit down plus startup cost, either consider in the cooling cost or banking cost. So let us take an example to understand this priority list method. Let us take an example. Let us take, there are 3 units available. There are 3 units in the generating station. Unit 1, Unit 2, Unit 3. The full load average production cost for Unit 1 is, let us take, this is 9 rupees. 9 rupees per megawatt hour. For Unit 2 it is 10 rupees per megawatt hour. For Unit 3, let us take, it is 12 rupees per megawatt hour. And the Unit 1, the maximum generation, maximum power and minimum power limits will be mentioned for any units. So maximum power generated for, let us take for Unit 1, let us take it as 450 megawatt. The minimum is 150 megawatt, and that is for Unit 2, let us take it as 650 megawatt, and for minimum is, let us take it as 200 megawatt, and that is for Unit 3, let us say it is 300 megawatt, and minimum is 100 megawatt. So these are the units available. There are 3 units available, and these 3 units, let us take the different loads for different hours. Let us take a load of 1400 megawatt for 1 hour, and next load is changed to, let us say, 1100 megawatt. Next, let us say load is changed to 450 megawatt. So under these 3 cases, let us determine the number of units to be committed, number of the units to be committed, or number of plants to be committed. So let us consider the first load case, 1400. If the load is 1400, then if the load is 1400 megawatt, then we need to, yes, the full load average production cost is already given. For Unit 1, the full load average production cost is less compared to the Unit 2 and 3. For Unit 1, it is 9 rupees per megawatt hour. For Unit 2, it is 10 rupees per megawatt hour. For Unit 3, it is 12 rupees per megawatt hour. So if you consider the load 1400 megawatt, so now all the 3 units are in priority order only, because the Unit 1 is taking less compared to the Unit 2 and Unit 3. So now we have the 3 units. So first preference should be given to the unit 1, second preference should be given to the unit 2, and third preference should be given to the unit 3. So if there is a load of 1400 megawatt, 1400 megawatt, let us write it in table form. Load in megawatt, number of units to be committed, number of units. So let us say the load now is 1400 megawatt, 1400 megawatt. So how many number of units to be committed in order to meet this 1400 megawatt? We know the generator 1 generates the maximum power up to, it is 450 megawatt. Generator 2 is 650 megawatt. Generator 3 it is 300 megawatt. So these are the maximum power generations by each unit. So generator 1 is, it is 450 megawatt maximum capacity. Unit 2 it is 650 megawatt. Unit 3 it is 300 megawatt. So if you add all these three maximum generation of all three units, 450 plus 650, this will be 1100 plus 300, it is 1400, right? So in this case, in order to meet this 1400 load, 1400 megawatt of power, the unit 1 should be committed, unit 2 should be committed, unit 3 should be committed. So all three units should be turned on. All three units should be turned on. So which means all three units should be committed. So let us consider the next load case. If the load is decreased to 1100, if the load is decreased to 1100, then we should our load is now 1100. We should meet this load 1100. So in this case, first preference is unit 1. So from the unit 1 you will get the 450 megawatt, right? From unit 1 you will get the 450 megawatt of power. Next preference is unit 2. So from unit 2 we can get the 650 megawatt. So put together, if we add the unit 1 and unit 2 power, unit 1 and unit 2 power, this will be 450 plus 650. So it is 1100. So if you commit only unit 1 and 2, if you commit only unit 1 and unit 2, under this case for decreased load, the load is 1100. So if you commit only unit 1 and unit 2, then that is sufficient to meet the required load. Then that is sufficient to meet the required load. So in this case, the unit 3 is decommitted or it is turned off. Unit 3 is turned off. If the load is decreasing further, let us take a 450 megawatt, 450 megawatt. Then if you look at the preference order, our first unit is generating 450 megawatt only, right? So maximum capacity of the first unit is 450 megawatt. So here unit 1 is sufficient to meet the required load demand. Here unit 1 is sufficient to meet the load demand. So likewise we need to list the number of units in priority order. List the number of units in priority order based on their full load average production cost. Based on their full load average production cost. So minimum cost should be the highest priority. Minimum full load average production cost should be treated, unit should be treated as highest priority, first priority. Likewise, you need to prepare the list. So this is about the priority list method of unit commitment solution. Next, we'll let us see the merits and demerits of this priority list method. So merits are here. We no need to go for the n number of combinations. Once you prepare the priority list, that is the final list. So you no need to go for the number of combinations. That is, you no need to check for the either unit 1, unit 2, unit 3 are satisfying the load, or unit 1 or unit 3 satisfying the load. So you no need to go for the checking the number of combinations. Here, second one is take only here we considered only one constraint, that is ignoring the minimum uptime and minimum downtime when it is applied to the thermal units. So here there are no complications, so complications are reduced. Demerits are startup costs here are a fixed amount, but in actual the startup costs will not be fixed, they will be varying in nature. So that is one of the demerit here. And no load costs are not considered. So here if the generator is running, it is not supplying any load means then it will be considered as a we have not considered any cost, but when the generator is running without the supplying any load, then also there will be a cost that we should consider in actual practice, but here in this method it is not considered. That is the one of the demerit.